Hello, smart mathematicians. Let's do question 10.3. In the diagram, BE and CD are diameters of a circle having M as the center. AE, you can see AE is drawn to cut CD. You can see CD here, to cut CD at F here. And then we're given that AE is perpendicular to CD. And then angle C is equal to X. Prove, giving reasons, that AD is a tangent to the circle passing through A, C, and F. We need to prove that the line segment AD, this line segment AD, is a tangent to the circle that passes through A, C, and F. So we need to have a picture of this circle. So let's draw a circle that passes through these 3 points, C, A, and F. So it's a circle like that. Do you see that? How can we prove that the line segment AD is a tangent? What do you know about tangents? A tangent is perpendicular to the radius or perpendicular to diameter, 1, and also remember the tan chord theorem. So if we manage to prove that this angle here, which is between the tangent and, it's not the tangent, we haven't proved it, so which is between this line segment AD and the chord AF, if it is equal to X, then AD is the tangent. So we need to prove that angle A2 is equal to X. So how do we do that? Remember, in the previous question, we found that A1 is equal to 90 degrees minus X. I've written it here. And then angle M1 is equal to 180 degrees minus 2X. Do you see that? Since CD is a diameter, so it means this angle CAD is equal to 90 degrees. So angle CAD is equal to 90 degrees. Why? Angle in semicircle. And then angle A1 plus angle A2 is equal to 90 degrees. Therefore, angle A1 plus angle A2 is equal to 90 degrees. Right, but we have angle A1, which is what? Which is 90 minus X. So you can say angle A2 is equal to 90 degrees minus 90 degrees minus X. Okay, then we can remove the bracket there. Angle A2 is equal to 90 degrees minus 90 degrees plus X. Then this is 0, so angle A2 is equal to X. So this angle here is equal to X. So therefore we can conclude and say AD, the line segment AD is a tangent. So this is a tangent. Why? Because of the converse tan chord theorem. Converse tan chord theorem. So that's the first part. Right, I'm going to show you 5 different methods or alternative methods. So it's going to be a long explanation. We've done the first one. Let's go to the second one. The second part, we have read the information, but now we know that the angle, we still want to prove that this angle is equal to X. This angle is equal to X. Remember, our circle is like this, so we still want to prove that this angle is equal to X. So we can find this angle. See that? And then angle EMD is subtended by arc ED at the center, and then angle A2 is subtended by arc ED at the circumference. You see that? So let's find angle EMD first. Angle M1 plus angle EMD is equal to 180 degrees. These are adjacent angles on a straight line. And then M1 is 180 degrees minus 2x. We've found this in question 10.2. Right, so 180 degrees minus 2x plus EMD is equal to 180 degrees. Then angle EMD is equal to 180 degrees minus 180 degrees minus 2x. Okay, and then 180 degrees minus 180 degrees is 0. So angle EMD is equal to 2x. If you distribute this, you get that. So this is 2x. And then, so we can say, therefore, angle A2 is equal to x because angle at center equals 2 times angle at circumference. Okay, so this angle A2 is equal to x. And then we can conclude, because this angle is x, and then this angle is x. So this is our chord here. And then this line is going to be the tangent, because this angle A2 is equal to angle C there. So we can say angle A2 is equal to angle C is equal to angle X. So therefore AD is a tangent. Okay. Y converse tan chord theorem. Right, and then we go to the third method. The third method, we still want to prove that this angle is equal to x. Okay, because this is the angle which is between the line AD and the chord. Right, if this angle is equal to x, then AD is going to be, if this angle A2 is equal to x, then AD is a tangent. Right, so we can start by finding this angle here. Angle M3 is 180 degrees minus 2x. Right, angle M1 is equal to angle M3, then equal to 180 degrees minus 2x. These are vertically opposite angles. These are vertically opposite angles. We can find angle A3. We can find angle A3 because these angles are subtended by the same arc BD. So angle A3, therefore angle A3 is equal to, what is half of this? 180 minus 2x. Half of 180 is 90 degrees. Half of 2x is x. So angle A3 is 90 degrees minus x. And then the reason here, angle at center equals 2 times angle at circumference. Angle center equals 2 times angle at the circumference. Right, and then if you check angle BAE, this angle BAE is equal to 90 degrees. Y angle in semicircle. And then we can find what? We can find this angle A2 here, because angle A2 plus angle A3 is equal to 90 degrees. But angle A3 is 90 minus x, so it's angle A2 plus 90 minus x is equal to 90 degrees. So angle A2 is equal to 90 degrees minus 90 degrees plus x. So angle A2 is equal to x. So this is equal to x. Therefore, angle A2 is equal to angle C is equal to angle x. Therefore, the line AD is a tangent. It is in converse tan chord theorem. That's another method that we could have done there. And then let's try the fourth one. We still want to find if this angle here, if A2 is equal to x, we know that this is the center of AE. AF is equal to FE. We talked about that in question 10.1. Right, so it means F is the midpoint of AE and M is the midpoint of BE. So it means AB is parallel to FM. So AB is parallel to FM. We can say that AB is parallel to CD. So let's write that. CD is parallel to AB. Right, why? Midpoint theorem. Midpoint theorem. Okay, we did midpoint theorem in grade what? In grade 10, if you remember. Right, okay. Right, and then so these lines CD and AB are parallel, and then someone can find this angle here, this angle, which is what? This angle is 90 degrees, angle CAD, angle CAD is 90 degrees, so meaning that this angle here is 90 minus x, 90 degrees minus x, okay? Right, and then if you check angle A3, this angle, and angle D are what? Are alternate angles. So you can say angle A3 is equal to angle D is equal to 90 degrees minus x, because they're alternate angles. They're alternate angles. And then CD is parallel to AB. CD is parallel to AB. So it means this one is 90 minus x. But angle BAE is equal to 90 degrees. So this angle here is also 90 degrees. This is 90 degrees since BE is a diameter. So this is an angle in semicircle. It's an angle in semicircle. So this is 90 also. So now we can say angle A2 plus angle A3 is equal to 90 degrees. And then angle A2 is equal to 90 degrees minus angle A3. And then angle A3 is what? 90 degrees minus x. Okay. Then we find that angle A2 is equal to x. Therefore, angle A2 is equal to angle C is equal to x. And then we can conclude and say AD. We can conclude and say AD is a tangent. AD is a tangent. The reason converse tan chord theorem. Okay. Right. Let's do the last part, the last method. This is our circle. So the other way, we can prove that this line AC is diameter. How can we do that? Is line AC diameter? Yes, it is diameter. And also angle CAD is equal to 90 degrees. Angle CAD is equal to 90 degrees. Why? Angle in semicircle. Remember, CT is what? CT is diameter. So this angle is 90 degrees. Alright, and then this angle also is 90 degrees. Okay. So it means AC is diameter. AC is a diameter. Why is it diameter? Because it's converse angle in semicircle. That's why AC is diameter. And then if you check, AC and AD are perpendicular to each other. So it means therefore AD is what? Is tangent. AD is tangent. Why? Because of converse radius perpendicular to tangent, or diameter perpendicular to tangent. So this one was very easy. This one was very easy. So that's what we're supposed to do. There's just any of these 5 methods we're going to give you all your marks. We're going to meet when we're doing question 10.4.